So percent means out of 100. So you could do a couple of things to change from a percent to a decimal. We could do, in our calculator, we could do 45 over 100 with a decimal. And if you do that, it's going to tell you 0.45 like this. That is one way you could do this. Another way is you may have learned in 6th grade a shortcut. Some teachers use Dr. Pepper. Some teachers use decimal fraction percent. So percent to a decimal is backwards 2 to the left with your decimal. So that might be another way that you've learned how to do this. 1, 2. So this is going to be 0.03. You can do this also in your calculator. So in your yellow calculator, if you have, we'll do this with the 132. If you type in your 132 with a decimal, and then you click on the question button, which is below the enter, and you choose percent and enter, it will also change it to a decimal. So when we put this in the calculator, we get 1.32. And I just wanted to give you several different methods that you could use to change from a percent to a decimal, because we are definitely going to need that. What about this 1.5? 1.5. You could use any of those methods. I tend to just move my decimal over 2 to the left. Do make sure when you do that, though, that you put in your 0 placeholder. So you should get 0.015. So we're going to look at what does an exponential look like by looking at zombies. So we have 2 strains of zombie virus in the United States. We have strain A, says each minute the original zombie infects 3 new people, but the new zombie cannot infect anyone. Okay, so I'm just gonna, I know you don't have a lot of space on the side unless you open up your paper. So I'm just gonna draw a little picture over here. So we have zombie number 1, we'll call it the OZ, the original zombie. And it's going to infect 1, 2, 3 people. Now those 3 people cannot infect anyone else, but this OZ can infect 3 more people, okay, and so on. So that's what strain A is going to look like. Strain B says each minute every zombie is able to infect 1 person, and new zombies are also able to infect people. So again, I'm just going to draw you a little picture over here. We have our original zombie, and they can infect this person, and they can infect this person, they can infect this person, they can infect this person, but then that person can also infect another person, right? So 2, I ran out of space there, so I'm going to go sideways, 2 and 2, but then, right? So they've infected this first person, that person infected someone, but now this person can infect someone, and this person can infect someone, and so on. Okay, does that kind of make sense? So what I want you to do, looking at those 2 pictures, is which strain do you think will create more zombies after 10 minutes? All right, just write it down, A or B, and then we're going to kind of look at some examples, and we'll go from there as to what does that look like and were you correct, okay? So, tracking the virus. The CDC wants to track the number of zombies after each minute. We're going to fill in the table. So, looking at strain A, which was this one up here, after 1 minute, how many zombies did we have? We have the original, and then we have in red 1, 2, 3. So how many is that? We have 4 total, right? Because this one on the 0 minutes was that original zombie. And then after 2 minutes, right? So that's going to be the red and the blue. How many do we have total on the red and the blue? 7. Okay, so do you see a pattern happening, or would you like me to draw another picture? Huh? What do we see happening? We're adding that 3 each time, right? So if we continued that pattern, how many would we have after 3 minutes? 10. Okay, keep going. 13, 16, 19, and 22. Okay? So what I want us to do, we're going to go ahead and we're going to make a graph of that so we can kind of see what's happening. But yes, in fact, good job on, this is just adding 3 each time. So when I come down here, okay, notice your labels, number of zombies in minutes. So at 0, I'm actually going to use red so it's a little easier to see. 0 minutes, we had our original zombie. And then after 1 minute, we had 4 total. And after 2, we had 7. So we're going to put that between the 6 and the 8. And then 3 was 10. 4 was 13. 5 was 16. 7 was 19. And then we ended, 6 was 19. And then 7 was 22. So this should look very familiar, right? So if I was to connect my dots, we can see that this is in fact linear, right? This is exactly what we've been doing since 6th grade, right? This is y equals mx plus b, right? Where our slope was that 3 and our b was the 1. That was what we started with, okay? When we look at strain B, we have the original zombie. Let me find my picture here, right? So we're going to look at the black. We had our original zombie. That was 1. So after 1 minute, then we are at, here's our original zombie and this person, right? So how many do we have after 1 minute? Just 2. Okay, so let's come over here. We'll put our 2. And then after 2 minutes, we have our original zombie, right? We have our first person who infected this person, but then the original zombie infected another one. So how many is that? We've got our original, and then we have 1, 2, 3, and 4 right here. So 1, 2, 3, and 4. Do you see that? So when we come over here, let's put our 4. Do you see a pattern here? Do you want to look at the picture one more time?
6.
Do you think it's 6 or 8? Let's look at that picture. I'm going to use a different color on the highlighter. So you've got oh, that's not a highlighter. Right, here's original, so 1 minute, 2 minutes, 3 minutes, and then the original zombie infected another person. This one infected this one and this one. So we're at 1, 2, 3, 4, 5, 6, 7, and 8, right? So here's my 8. So what's the pattern happening here? Times 2. Times 2. So what is 4 going to be if we're following this pattern? 16, and then 32, 64, and 128. So let's put this on the graph, right? And notice our scale is different. It is by tens, right? So 0, 1, you're going to have to get real close to that line. 1 was 2. 2 was 4, so it's about halfway. 3 was 8, so we're almost to that 10 line. I know those dots are kind of tiny. And then it jumps, right? It jumps 4 to 16, so about halfway between 10 and 20. And then again, we jump to 32, so a little bit above that 30 mark. And then again, 64, between 60 and 70. And then 128 would be like way, way up here. Okay, so when we draw this line, I want you to note it is very different than any of the lines we've ever done. It is curved. It kind of starts off slow and then it gets steep really quick. So this is actually our new information here. This is called exponential. Okay, and that's that y equals ab to the x. So the equation for this one would be 1 times 2 to the x. This one's always going to have an x on it. So just a little quick brain trick to keep track of the 3 types of graphs we're going to talk about this year. So linear, right? Our graph is in fact just a line. In the spring, we're talking about quadratic. So we're going to put a U there. A quadratic is going to be a U-shaped graph where it goes down and then back up, or it goes up and comes back down. It's going to be, you know, a curve like this. The one we're doing now is exponential. So I'm going to kind of draw my X kind of fancy, right? So it's either going to go down or it's going to go up. It's going to be a curve, okay? But that curve, it's going to kind of start off slow and then get real steep. We have lots of different vocabulary words for all of these, right? Linear, we had rate of change, we had slope, we had constant, okay? When we talk about exponential, we have growth, decay, constant ratio. Notice it says ratio, not rate. Rate is going to be linear. In 8th grade, you talked about interest, right? So you did a little bit with this. You just didn't know what it was called. Invest, multiplies by a percent, decreases by a percent. If we have percentages, it's going to be exponential. Appreciate, depreciate, double, half, and percentages. And remember, we always want to change our percent to a decimal. Always. That's going to be really important here. So I want to show you 2 different types of these. One where just these first 2 vocabulary words, one where it's growing and one where it's decaying. So we have our parent function here. This is going to be super important, right? Our linear parent function was y equals x. And we're going to... you can do this in your yellow calculator. You can use Desmos. So we're actually going to graph that. We're going to graph 1 parentheses 2 to the x. And to get that x like that, you're going to use that caret like we talked about when we were doing our exponent rules. Or you can do this in Desmos and use that AB button. Okay, so we're going to come here. We say -1 was a half, 0.5. We had 1, and then we had 2, and 4, and 8. So when we graph that, 0.5, 1, 2, 4, and 8. And again, when we draw that line, I do, and I'll go back to the graph in just a minute. Notice I'm not actually crossing that x-axis. Okay, and it actually cross it. So when you draw your picture, make sure you do that. Things I want you to realize when we look at this, okay? We've got, it's going up. So this is going to be what we call a growth. Okay, because our graph it's increasing. I'm going to highlight this x-axis right here, okay? An exponential is going to get real close to that line, but it's not actually going to touch it. And it has a special name. This is called an asymptote. And that equation for our x-axis is y equals 0. If you remember when we did OIVUX, right? That's a horizontal line, so it's y equals, and we're crossing at 0. I say y equals 0, okay? I want you to make sure you pay attention to that. You're going to see it a lot. So on an exponential, it will get close to that line, but it won't actually cross it, okay? If we look at, we're going to look at one more over here. And we're going to say y equals 1 times 0.5 to the x power. Okay, so let's see what that looks like. Right, and when we looked at that table, the table is actually kind of backwards of what we had before. Now it's 8, and then 4, 2, 1, and 1/2. So -3, 8, and then 2, -2, 4, -1, 2, here and here. So it's gonna, and again, we get close to that. We call it the asymptote. Okay, and it's still y equals 0, but we're gonna get real close to that, but it's not actually gonna touch it, okay? This is going down, so this is what we call a decay. So you can compare the two. We talked about that vocabulary, growth and decay. So the asymptotes are the same. It's just one is going up and getting bigger and one is going down. So let's talk about what numbers are making that happen, okay? So the A, which is that first number, and in our examples it was a 1. This is going to be our y-intercept. I know when we did linear, it was B, so that's a little confusing. So we'll just keep practicing that. This is also what we call our initial value, right? We started with 1 zombie. Now the B, that's going to be your constant ratio, not rate, ratio. All right, and we're going to put in parentheses here. This is what we multiply by. So when we did our zombie, we were multiplying by 2, okay? Or on that second example, we were cutting everything in half. Things I want you to know, if the B is bigger than 1, we will have a growth. So like on our example right above in blue, the B was 2 and our graph was going up. If our B is less than 1, like on the red one, the 0.5, then it's going to be a decay. It's going to be going down, okay? Those are going to be important things for you to pay attention to so you can like match graphs and things like that. This equation here, you've probably saw this in 8th grade when we were doing interest. We are going to talk about is that 1, everything is based off of 1. So that 100 or that 1.0 is going to involve our percent. We have to make sure we change those percents to decimals. And R is going to be our ratio, not a rate. Rate tells us linear, ratio. So here's what that graph looks like. Here's our table, and we're going to fill that in on our paper like that here. So it gets really close to the x-axis, but it doesn't. This one. So here is 1 times 1/2 to the x, and notice this one is going down, and it is also still getting really close to that x-axis, that y equals 0 line, but it's not going to touch it, okay? So let's graph. So now that we know what the A and B are, let's talk about, let's see what's happening, interpret, identify, and interpret, and this is what we're going to do in our practice. So I just want you to tell me what A is and what B is in this equation. What's my A? What's my initial value? 50, very nice. That's where we would start. And what's my B? It's the 1/2, right? It's always going to be the one that we're multiplying by. We can also write this as 0.5, or we can write it as 50%. All of those would be acceptable. Do you think if we graphed this based on the B, would it be a growth or a decay? It's going to be a decay because it is less than 1 or less than 100. Good job. And we are actually going to decay by, I wrote by twice, 50%. So let me talk about that little equation we looked at with the 100 plus or minus. Since it's a decay, we've got 100 minus our 50 means that we have 50 left. So we're decaying by 50%. Let's look at number 2. What's my A on number 2? The 100. What's my B? 1.25. You can also write 125%. Only change it to a percent if they ask that, though. Is this a growth or a decay? Is the B bigger than 1 or 100 in this case, right? Or less than 1? It's bigger, so it's going to be a growth. And if you're not sure, you can always graph it. So this is going to be, since it's a growth, we've got 100 plus something is 125. Well, what plus 100 is 125? 25. So it's a growth by 25%. Okay, and that's probably the trickiest part, and we'll continue to practice that the next couple of days. Here, what's my A? 350, good. What's my B? 0.45 or 45%. Growth or decay? This is a decay, okay? So again, if I could spell right, there we go. Decay by, now this is not a decay by 45% because remember, we're doing 100 minus the 45 is 55. So we're decaying by 55%. That 45.45 or 45% is what is left. We're missing a number on number 4. What needs to be in front of that parentheses? A 1, good. And is that your A or your B? That is A, good job. What's our B? 3/2. You could also write that as 1.5. Growth or decay? Growth by what? 100 plus what is 150? 50, good. So this is increasing by 50%. So here's a real life example. Basketball tournament started with 256 teams. Is that A or B if that's what we're starting with? That is A. Very nice. So let's label that. And after each round, half are eliminated. Half are eliminated. A or B? That is B. So we're going to write, first of all, is this a growth or a decay? It's going to be a decay because the number of teams is going down. So when we write our equation, you can use f of x or y. Remember our format, a, b to the x. So our a was 256 times, what was our b? Half, and then to the x power. Okay, and when they do Final Four and those kinds of basketball tournaments, they use a bracket like this, right? Once you lose, you're out. So that's kind of how they go from, I think they start with 64, and then they get half, they're eliminated half and half till they get to the champion. Drake is investing $15,000. Is that A or B? That is A, and a common ratio. This is our B. Now, what do I have to do with that percent? What do we change it to a decimal? Definitely. So if I have 105.5% and I'm going to change it to a decimal, you can change that all of the ways we talked about at the very beginning. You can divide it by 100. You can move your decimal over twice. You can use your calculator. No matter which way you do it, you should get 1.055. So, is this a growth or a decay now that we're seeing it like that? It's a growth. His money is growing, and that's what you want when you invest your money. You want to make it grow, right? We don't want to lose money. So, our equation, y equals, what's my A? 15,000 times, what's my B? Write it as a decimal to the x power. All right, another real life problem. The equation represents the effectiveness of Tylenol after a certain number of hours, 400 times 0.8 to the x. Which statements are true? Select 2. Okay, before we do that, I want you to just analyze this equation, everything we know. What do we know about the 400? That's our A. This is our initial amount or value, right? So 400 milligrams or whatever you took to start with. Okay, what about this 0.8? What does it tell us? That's our B, and it's a decay. It is less than 1. So remember, we're going to have to do, you can do 1 minus 0.8, or you can do 100 minus 80. What do we get? 20%. So this is a decay by 20%, or 0.2. So those are going to be important things to pay attention to, so we can look at our answer choices here. The effectiveness is decreasing by 20%. Is that true or false? That is true. What about the initial amount is 0.8? No, that's false. That was our B. The starting amount is 400. That is true. And the effectiveness is increasing at a rate of 400%. That is false. So just A and C. Okay?